Hi friends. Okay, so today's date is Tuesday, April the 28th. Our assignment after today's lesson will be on IXL, which will be Q3. And the name of the game today is Decomposing Fractions. I think today will be a pretty easy day for us all. I think that we really did a good job of mastering this concept when we were back in Mr. Hogan's classroom. So I think that today should be a pretty awesome day for you all and should give you enough time really to get all the other things taken care of this week, especially all that fun stuff that you guys are doing in both reading and writing. So, decomposing fractions. The golden rule of decomposing a fraction is what is here. However you split that fraction into parts, so you're going to split it into parts, and as long as all of those parts add back up to the original fraction, you're correct. So yesterday we focused on adding and subtracting fractions. Well, today we're going to be working with fractions of the same denominator, but we're going to decompose them. We're going to split them apart. Now, we talked in class a long time ago about how decomposing is basically like breaking something down. If a plant dies out in the wild, like if a tree is struck by lightning, it's not going to live anymore. It's just going to decompose. It's going to break down into smaller pieces. So that's essentially what we're doing here with these fractions. Let's take an example, look at an example of something easy. 4/8. Well, 4/8, I realize that I don't have all 8 pieces here. I only have 4 of them. But I could break those pieces, those 4 pieces, I could pull those out into smaller bits. Instead of having 4/8 written out, I could have 2/8 plus 1/8 plus 1/8. Let's double check and make sure everything adds back up. My denominator does not change, but 2 plus 1 is 3, plus 1 more is 4, and 4/8 is equal to 4/8. I could also do it 1/8, 1/8, 1/8, 1/8, 1/8. I could do something as easy as 2/8 plus 2/8. Again, that golden rule, as long as everything adds back up to the original fraction being 4/8 in this case, as long as it all adds back up, we're set. So 2/8 plus 2/8, yes, of course, that's 4/8, and 4/8 is my original. Now, I have a problem here for you, and this looks very similar to what you'll be doing on IXL today. This is a fraction bank, and these are going to be all the different choices that you will see down at the bottom of your screen. You may see a fraction like 6/9 equals blank plus blank plus blank. And you're going to have to think about which fractions you can use to put in those blanks. Remember, as long as it adds back up to 6/9, we're set. So I could already look down here and recognize that if my total is going to be 6/9, does 9/9 even make sense to use? Absolutely not. Same goes with 8/9, same goes with 7/9, and I say that because they're all already larger than the numerator of 6. Now 6/9 looks pretty good, but also, if I put 6/9 down, I haven't really decomposed it, and I can see that there's 3 blanks, which means that the computer is going to want me to take 3 different fractions to make it add back up to 6/9. So 6/9 can't work. And you know what's funny? Neither can 5/9, because if I had 5/9 here, the only other thing I could add to it would be 1/9. 5/9 plus 1/9 plus something else. I don't have a 0 in my fraction bank, so 5/9 can't even work. But let's take a look at what I can do. I could totally put down 2/9. 2/9 so far. 2/9, and I still have to get, well, let's see, 6 minus 2 is 4. I could do 4/9. No, because that wouldn't work for me. Well, hey, I could do 3/9. 2 plus 3 is 5. Well, that only leaves me with 1 more 9th. And I'm all set. And I actually think that on the computer, you can reuse some of these numbers. So I could have done 2/9 and 2/9 and 2/9. 4/9, 1/9, 1/9. There's a whole bunch of different ways I could do it. But make sure you're paying attention to what makes sense. If I've got 3 blanks, I have to use them all. Next one is 18/9. Now, this is what you call an improper fraction because it's got a larger denominator I'm sorry, it's got a larger numerator than it does a denominator. And when I have a larger numerator, that tells me that this fraction is already greater than 1. What's beautiful about these types of fractions is the fact that I can still decompose it. I can still pull out pieces, and I can pull out up to 18 different pieces if I really wanted to. But realistically, let's pull out something easy. I'm going to pull out, 10 twelfths so far. Of my 18 twelfths, I've pulled out 10. Well, I'm going to pull out one more. 10 twelfths plus 1 twelfth leaves me with 11 twelfths. I could still do more. 4 twelfths plus 1 twelfth is 5 twelfths plus 10 more is 15 twelfths. Well, why don't I just make this? Let's see, 15, why don't I just make this 3 more? And here I've decomposed 18 twelfths 1, 2, 3, 4 times. I've pulled out 4 parts from that total. 10 plus 1 is 11. 11 plus 4 is 15. 15 plus 3 more is 18. If it adds back up, I'm all set. Here is your pause and try for today. It's 16 twentieths. Your answer could be totally different from mine, but pause the video here, and why don't you decompose this fraction? Why don't you decompose this fraction? Let's challenge you guys. Why don't you guys do it 3 ways? Go ahead and pause here. One way you might have done this, as long as all your pieces here are out of 20, your total is 20 pieces. Let's say I did 6 twentieths plus 6 twentieths. 6 plus 6 is 12. 12 minus 16, if I had to find out the remaining or the difference of my bits, you may have done 6 plus 6 is 12, plus 4 more. You could have done 6 plus 6 plus 4. Any variation works as long as it gets you back to that beginning problem. You guys will do great today. Like I said, today is Q3 on IXL. Good luck. I'll see you guys again tomorrow.